Welcome back to my conundrums, and we're still talking about limits here, but when a limit leads to infinity, it actually is closely related to the concept of a vertical asymptote. So the definition of a vertical asymptote is given right here. If f of x approaches infinity or negative infinity as x approaches some number c from the right or left, then the line x equals c is called a vertical asymptote of f. So the line is not actually part of the graph, but it's helpful in graphing to draw those vertical asymptotes as broken lines. Now I'm going to let you read this existence of a vertical asymptote here, but really I can easily tell you in layman's terms. Basically, if you have a function like a rational function like we have like these down here, basically you get a vertical asymptote at any number that makes the denominator 0, as long as it doesn't also make the numerator 0. So for this function, you get a vertical asymptote at x equals 5, because x equals 5 makes the denominator 0, but it doesn't make the numerator 0. Now, it'll be helpful if I show you the graph. So here's the graph of that function, and notice that I drew a broken line here for x equals 5. And notice as you approach x equals 5 from the left, the graph goes to negative infinity, and as you approach 5 from the right, the graph goes to positive infinity. So you can easily see that x equals 5 is a vertical asymptote. Okay, now let's take a look at this next one. This next one, the denominator is x squared minus 3x minus 4. Now I'm going to go ahead and factor that. That factors into x minus 4 and x plus 1. So here there are two numbers that make the denominator 0, x equals 4 and x equals negative 1. So I would say, since they don't make the numerator 0, we can say that we would get two vertical asymptotes here, one at x equals 4 and one at x equals negative 1. Let me show you that one. So over here, you see this is the line x equals 4, this blue line, the broken blue line. And so you can see as you approach 4 from the left, the graph goes to negative infinity, and as you approach 4 from the right, the graph goes to plus infinity. The green line here, that represents negative 1, and see, as you approach negative 1 from the left, the graph goes to negative infinity. As you approach negative 1 from the right, the graph goes to positive infinity. So there you have two vertical asymptotes. So on this third example here, I have x minus 3 over x squared minus 9. So if I factor the denominator, I get x minus 3 times x plus 3. Now notice I said if x is negative 3, we get a vertical asymptote, because certainly if x is negative 3, that'll make the denominator 0. So you might say, well, what about x equals positive 3? Wouldn't that make the denominator 0 as well? Yes, it would, but that would also make the numerator 0. And so when the number makes both the denominator and the numerator 0, you get a hole at that value. So we don't get a vertical asymptote at x equals 3. We get a hole at x equals 3, but we get a vertical asymptote at x equals negative 3. So let me show you that. So here's the graph, and this green dotted line, broken line here, is x equals negative 3. And so you can see that as we approach this from the left, it goes to negative infinity. As we approach it from the right, it goes to plus infinity. Okay, so what happens at 3? Well, let's see if we can show you. Let's ease up on 3. Let's see if I can get there. Whoops, I just passed it. Come on, give me 3. All right, let me try something else. I'm supposed to be getting a hole here, but I can't get it to land on it. All right, just pretend like there it was. Just passed it, almost had it. There we go. So there at 3, you get a hole in the graph right there. All right. So that would not be, so you wouldn't get a vertical asymptote there. Now you can do this practice problem if you want to, and you should be able to determine that you get a vertical asymptote at x equals 4 and x equals 0, because if you plug those numbers back into this, it'll make the denominator 0. Okay, so here's some other examples here. Let's see, let me see what I did here. So on this one, I factored the numerator into x plus 4 and x minus 2. I factored the denominator into x plus 2 and x minus 2. Put a parentheses there. Now, so you get a whole at x equal 2, because that makes both the numerator and denominator. So you get a whole at x equal 2 and a vertical asymptote at x equal negative 2. This one, if I factor the denominator, I get x times x minus 4. So I get a vertical asymptote at x equal 4. But I get a whole at x equals 0, because that would be 0 would not only make the denominator 0, but it also make the numerator 0. Now let me just tell you, if this was a number like 3 on top, then I would get a vertical asymptote at both x equals 0, which is the y-axis, and x equals 4. But it wasn't 0, it wasn't 3, it was x. All right, and then this one, if you factor this, it factors into x plus 2 times x squared minus 2x plus 4, and the bottom factors into x plus 2x minus 2. So negative 2 would make both the numerator 0 and the denominator 0, so we get a whole at negative 2, and x equal 2 would just make the denominator 0, so we get a vertical asymptote at x equal 2. This is just an example of how you can determine limits. We covered this in the previous video, but you remember I told you that if you wanted to find the limit of this 5 over x minus 1 as x approached 1 from the right, just pick a number to the right of 1 and see what's happening. So at 1.1, if you plug 1.1 in there, you get 50. If you plug 1.01, you get 500. 1.001 into this, you'll get 5,000. So it looks like as x approaches 1 from the right, this is going to plus infinity. And then if you want to see what's happening as x approaches 1 from the left, just plug in numbers like 0.9, 0.99, 0.999, and you'll see that this is going to a very large negative number, so that limit would be negative infinity. And you can see the graph over there. Here's another one. This one, the denominator factors into 2 minus x, 2 plus x, so we know this would not be defined at x equal 2 or negative 2. So let's look at what's happening to this as x approaches positive 2 from the left. So if you plug in numbers, remember, we know as x approaches 2, this has to go to infinity or negative infinity. So we just need to determine which one. So if we approach 2 from the left, we go through 1.9, 1.99, 1.999, etc. So if we plug those numbers into this function, we got a large positive number. So that tells me that that limit's going to be plus infinity. And then if I want to find the limit of this number from the right, then pick numbers to the right like 2.1, 2.01, 2.001, and notice you're getting a large negative number there. So that limit's got to be negative infinity. And you can see over here the graph. This vertical line, I should have made it a broken line, but this is your vertical asymptote at x equal 2, and you can see as you approach 2 from the left, it goes to plus infinity, and as you approach 2 from the right, it goes to negative infinity. There's also a vertical asymptote at negative 2, but I didn't want to do both of them. Alright, so that's how vertical asymptotes and limits that equal infinity or negative infinity are related. So in the next example, the next video, I'm going to bring in horizontal asymptotes and limits as x approaches infinity or negative infinity.